Okay, this second video is on the standard normal distribution, and we're going to talk about how to use this standard normal table. Okay, and we're going to use this table to find areas underneath the curve. So let me first describe what the standard normal distribution is and what I mean by areas underneath the curve. Okay, so the standard normal distribution is a normal distribution that has 0 in the center, and along the bottom are the z-scores. 1, 2, 3 standard deviations above the mean. 1, 2, 3 standard deviations below the mean. So -1, -2, -3. And so these are the z-scores. Okay, you can also think of it as a normal distribution with a mean of 0 and a standard deviation of 1. Okay, but the idea is this is a normal distribution that has z-scores along the bottom, as opposed to like x values, like the heights of adult males or the weight of newborns or whatever. These are z-scores, and it's used as a mathematical tool. There's probably not any data sets that actually have a mean of 0 and a standard deviation of 1. So we use it because we're going to put the area, we're going to use this table to find the areas underneath the standard normal distribution, and we're going to be able to use that in the next video. We'll see that we're going to be able to use that with the z-score formula to find the areas under any normal distribution. Okay, so let me share what I mean by areas. Okay, so remember, within one standard deviation there was 68% of the area. Okay, now or I should say 68% of the data. So this portion here is 68% of the data. Now, the area is just the decimal form of that percent. And the table gives all the areas to 4 decimal places. Okay? So the area between -1 and 1 is 0.6800. When I convert that to a decimal, that means I'm just moving the decimal point over 2 places, and I'm getting 68%. Okay, so the area is the decimal form of the percent, and you can think of the total area here, 68% of the area is right here. Okay, now you can get areas for other z-scores here. Let me show you how this works. Okay, so 0 is in the center, okay, and we say that the total area under the curve is 1. You can think of the total area as being 100% of the area, and the decimal form of that would be like this. So the total area under the curve is 1, and so let's say I take a z-score here of a -1.34. So that lies below the mean. It lies, past 1 standard deviation, and so you got this z-score here, and it's going to have a certain percentage of data below that value. So this area here is actually what the table's going to give you when you look up this z-score. And this is really important to realize, that whenever you look up a z-score on the table, and you look up a z-score by looking here and here, and I'm going to show you that in a second, but you look up the z-score, the areas are in the middle, and they're 4-digit decimal numbers, and they represent the percent, okay? But when you look up a z-score on the table, it always gives you the area below that z-score, okay? And these are negative z-scores, so 0 is here in the center. This is a negative z-score below 0. So this is the negative side of the table, and this is the positive side of the table, okay? So 0 is right there, and so the z-score is right here. And you're going to get you're going to get all the area below the z-score. So the table, whenever you look up a z-score, positive or negative, you're going to get the area that lies below that z-score. And it'll always be an area between 0 and 1. Okay? In fact, if it's a negative z-score, you'll always get an area below 0.5000. Okay? Because the mean, half of the data, and below the mean is half of the data, 50%, and that's like 0.5000, right? And so any negative z-score, all these areas are below 50%. All of these areas are above 50%, because once your z-score is positive, all the area below that is going to be more than 50%. So how do I look up this z-score here? Okay, let me give you kind of an example of the table here. You're going to look up negative 1.34 by doing this. You're going to look up on this column here, you're going to look up negative 1.3. Okay, so the ones place and the tens place, you look up in this column. So in other words, this column, this first column, I look up negative 1.3. Okay, and then the hundredths place is a 4. And so you're going to look up the hundredths place along the top. So until I get to, I'm going to go over till I get to 0.04. Okay. Oh, excuse me. So where this row and this column intersect, you're going to get a 4-digit decimal number. Okay, so negative 1.3.04, where that row and that column intersect, I get the number 0.0901. And so this is going to be the area that lies below that z-score, okay? And that's really the decimal form of 9.01%, okay? Now notice the table will always give you the area to the left of, so make note of that. The area on the table is always to the left of the z-score. And this is true if you, whether you look up a negative z-score or a positive z-score, okay, it'll always give you the area below that, okay? So let me do one more example of this. So let's say I want to know the area. I want to know the area, let's say, below 2.76. So that's my z-score, a positive 2.76. So that's 3 standard deviations above the mean. So that's way above the mean. And I want this area here, okay? So what do I do? I look up, I'm going to go look up 2.7. I'm going to go over to 0.06. So the ones and the tens place I look up here. The hundredths place I look up there. Where these two intersect will give me the area below that. So I go to the positive side of the table now. I look up 2.7, 0.06. So where that row and that column intersect, I get 0.9971. And that's going to be this area below the z-score, 0.9971. And that's really the decimal form of 99.71% of the area. That's like pretty much all of the area lies below 2.76. Okay? So that is how you use the table. Now, when we use the table, what we're looking for is the percentage of the population or the distribution, whatever it is, if you're dealing with adult males or weight of newborns, the weight of products. We're looking for the percent of products that are going to be either below a certain z-score, above a certain z-score, or between 2 z-scores. So there's actually 3 cases. And you're going to use the table in a little differently in each case. So the first case is percent below a z-score. The second case is a percent above a z-score. And the third case is the percent between 2 z-scores. So let's look at each of these individually, okay? So the first case is the percent below a z-score. Okay, this is the one that we've been doing. This one you use the table directly. The area on the table is your answer, right? So if you have like 0.36, you want to, and let's say this is a negative 0.36, you want to know this area below that. Okay, how do you do it? Well, you look up on the negative side, 0.3, 0.06, and where these two intersect, you get the area 0.3594, 3594. So 0.3594. That is the area below this z-score. And the table gives you the area below. So if you want the percent below, you just move the decimal point over. So what percent of the distribution lies below this z-score? 35.94%. So if I were to write a rule here, I would just say look up z-score on table and the area on table is decimal form of desired percent. Okay, that would be the simplest case. Okay, so now let's consider when you want to find the percent above z-score. Okay, to see why we do what we do here, just consider a couple examples here. Okay, and maybe I'll get another sheet of paper here. So I just want to show a couple examples. Let's say you had some z-score where this was, let's say, 10% of the area. Okay, if that were 10% of the area, then up above would be 90% of the area, wouldn't it? Because you're either below or above. They have to add together to be 100%. Okay? So similarly, let's say this was a z-score where you had, let's say this is 25% of the area. Well, what would this be? What would the area above be? It would be 75%, right? Because you're either below or above. If this is 25, that's 75. Okay? And they add up to 100%. So in a similar way, this, let's say, negative 1.34 that we did, we found that this area was 0.0901. Okay, the area above is 1 minus this. So it's kind of like taking 100% minus 90%, or 100% minus 10% is 90%, or 100% minus 25% is 75%. So instead of taking 100% minus the percent below, you're taking 1 minus the area below. And you would get like 0.9099, right? So the area above would be 90.99%. Okay, you're either below or you're above. Okay, and the relationship between the two, the table gives you the area below. You got to subtract from 1 to get the area above. So let me show you an example of this. So let's say I want to find the percent of area. Let's say maybe that's above, we'll say 1.89. So I want to find this area above the 1.89. So I got to look up this on my table to get the area below, right? So go to the positive side, look up 1.8, and then 09, and then where these intersect, I get 0.9706. 9706. Okay, so if I want the area above, I just take 1 minus that. Okay, and that's like 0.0294, right? So it'd be like 2.94% of the area. So what percent of the area lies above a z-score of 1.87 or at 1.89? 2.94% of the area. Okay, So that's how you do it. So if I were to write a rule, I would say look up z-score on table, and the desired area is 1 minus the area on the table. And then the area is the decimal form of the percent. So it's, you pretty much look it up, but then you have to subtract from 1 to get the area above. Okay, so that's the second case. So finally, the third case is when you want to find the area or the percent between two z-scores. Okay, and this is the last case here. So here's the idea. Okay, so let's say we have a couple z-scores. Let's say this is like negative 1.73, and we'll say this is like negative 0.84. And I want to find the area between these two. Okay, so you're going to shade the area between those two. That'll be the decimal form of the percent of the distribution that lies between there. Okay, so when I look up this one, I'm going to get all the area down, all the area from negative 0.84 on down, and that's too much area. So what I actually want to do is I want to subtract the area below the other one. Okay, so I'm going to go to my negative side of the table, and I'm going to look up negative 0.84, and that gives me 0.2005. And then I look up the area for negative 1.73, and that gives me 0.0418. Okay, and then what I need to do is I need to subtract those two areas. And that gives me the areas between, okay? And this gives me 0.1587. So what's the percentage? 15.87%. Okay? So if I were to write a rule here, I would say look up both z-scores and subtract the two areas on the table. And it'll always be the larger area minus the smaller area, or the area for the z-score on the right minus the area for the z-score on the left. And that'll give you the area between. Now let me show you one other thing that you need to be aware of is, let's say you're given a problem here. Let's say we have negative 1.23, and let's say this up here is like 3.76, so it's way up there, right? And you want to get the area between these two. Okay, so it's going to be the difference between these two. But if you try to look that up on the table, you're going to find that it's not on the table. Okay, so the table goes up to 3.49. So that's as high as the table goes. Okay, so what we're going to do is write a rule down here that says for z-scores greater than 3.49, use 0.9999 for your area. So for anything greater than 3.49, just assume that the area is 0.9999. So what's going on there is that's as big as you can get to 4 decimal places without being 1, right? So it's an approximation. Anything bigger than that is pretty much all of the area. Not quite 1, but that's as big as you can get without being 1, at least to 4 decimal places. Okay? And then you look up the other one, negative 1.23, and that is 0.1093. 0.1093. So you would subtract those two, and that gives you the area between. Okay, so it's 0.9999 0.9999 minus 0.1093, and you get 0.8906, which is like 89.06%. Okay, so similarly, if you have a really high negative z-score, like something beyond negative 3.49, you only get a little bit of area. And so on the, like we wrote here on the positive side of the table, on the negative side, write for z-scores less than negative 3.49, use 0.0001. And this is as small as you can get to 4 decimal places without being 0, 0.0000, which is 0. So for anything smaller than this, for anything that lies way out here, the little bit of area you're going to say is 0.0001. The true area is probably smaller than that, but that is the best approximation you can do to 4 decimal places. Okay, so that's what you do when you find the area between 2. So let me finish with one more quick example. Let me just do negative 1.00 and 1.00 and I'm going to find the area between these two. Okay, so I'm going to look up those two and subtract the areas, and let's see what happens. Okay, so 1.00 is 8413. And then negative 1.00 is 0.1587. Okay, so let's subtract these. 0.8413 minus 0.1587. And look at what we get. I get 0.6826. And look at that. What is that? 68.26%. Okay, notice the percentage I gave before. I said between 1 standard deviation is 68% of the data. Well, there you go. It's actually 68.26%, but when we round to the nearest whole percentage, we would round to 68%. So that's actually where that number comes from. You get it from this table. Okay? And so that is how you use a standard normal table. So we'll have one more video that talks about how to put this together with the z-scores in order to solve percentage problems for actual normal distributions.